So I wanted to go give you some background on Numerai. So Anson was talking about staking, and he means staking Numerai, our own cryptocurrency that we made about 2 years ago. And the reason people kind of liked Numerai and started using Numerai was because it was really easy to use. And the whole point of it was very simple. If you put money on things, it's because you believe in them. That's it. That's kind of the main thing we're talking about today. And the reason for Numerai was all about overfitting. And it was the kind of final piece we needed to prevent overfitting, because you're not going to overfit if you have a good, if you have money on your model. So when we launched NMR, didn't really know what to expect in terms of its usage, but it grew really well. So this graph is showing that there have been about 50,000 stakes on Numerai with this token. So just for perspective, most crypto projects have no users. And even the ones that do, the big name projects like Augur or 0x, sort of have like 60 users. And those are the good projects. So crypto is very early, but Numerai somehow took off. There was a time actually when CryptoKitties, it was this Ethereum application that kind of blew up, and a lot of people were buying and selling kittens on the blockchain. And I remember this article about it. Look how good this is. Ethereum's really taking off. And there were more stakes on Numerai that weekend than there were CryptoKitties sold. So it's sort of like this weird success story that not many people know about. So for some reason, the rest of crypto was kind of like writing these kind of pseudo mathematics kind of white papers that don't make any sense. I actually made this on a website called MathGen, and you can just make a fake math paper. And so that's what the other crypto projects started to look like, and we were seeing all these really, really bad ideas. But you don't really need a white paper to make a product, and I don't think Mark Zuckerberg wrote a white paper like this when he was making the like button. He just made it. And so that's kind of been a little bit of our philosophy. That being said, we did have a white paper. We were super cool. And it was like, but it was short. It was like 2 pages. So what was the first thing we could do with Numerai to make it even better? We were like, people are using this. Maybe other applications could really benefit from staking and griefing. And so we made this application called Erasure Quant. But to do this simple application, we actually had to make a whole protocol called Erasure. And that was kind of the hard part. And about a few weeks ago, we released Erasure Quant. And this is what it looks like. It basically just looks like a normal website. But what you're kind of not seeing is the kind of underlying parts of the protocol. So this is a real user. His name's Robot Unicorn. He's staked 40 NMR. So that stake over there is a real stake on the blockchain. All of these predictions he's uploading are files that are landing on IPFS. So this is the first application that's really using Erasure. But it's very like Numerai specific. It's kind of like Numerai as a way to crowdsource more data, whereas Numerai is more about crowdsourcing machine learning. So we just wanted to make the case that if you couldn't make Numerai or Erasure Quant without without staking, then maybe there's like tons of other applications that you couldn't make without staking. So I want to introduce Peter, who is VP of Erasure, and he's going to describe how we've made a new application called ErasureBay. So Peter.
Thanks, Richard. Hi, everyone. My name is Peter. I recently joined Numerai to lead the Erasure team. And I want to start and just take a little bit of a step back from all of this. And that'll help us understand where Erasure came from. And that, by knowing that, I think that'll allow us to think about how far it can go. When we try and abstract what the Numerai Data Science Tournament is and what Erasure Quant is, effectively, there are places where sellers, in this case data scientists, can upload their predictions and they can stake on those predictions based on their confidence. And then on the flip side, we have a buyer, in this case Numerai, that will buy those predictions and will either burn a reward based on the stakes. But the abstraction of this is an information marketplace with a buyer and a seller, and predictions are only a very small subclass of the valuable information that is out there. And this is how we get to ErasureBay. ErasureBay takes the market primitives of seller staking and buyer griefing to enable a decentralized marketplace for price discovery and transactions for any type of information. But every marketplace needs somewhere to start. A niche use case, some sort of data that can be transacted on it to bootstrap. And in the case of ErasureBay, while it will work for any type of information, we think that key first use case, the type of information that's screaming for exactly this, is zero-day software vulnerabilities. Now, for anybody not familiar with the term zero-day, a zero-day is a critical software flaw that's discovered in code that's already live and in production. And the name zero-day comes from the fact that if you're Apple or Google and you have a zero-day discovered in your code, you have exactly 0 days to fix it before criminals or hackers could be exploiting it. 0 days are extremely serious, and almost all the big tech companies have bug bounty programs where they'll pay big bucks, sometimes upwards of $1 million, to security researchers who report 0 days. So let's say that you're a security researcher and you found a critical bug in the latest version of iOS. You'd like to claim that big bounty from Apple. So what do you have to do? Well, the first thing you have to do is you need to go to Apple and you need to disclose everything about what your discovery is. And only after that, once Apple has had a chance to look at what you have, will Apple decide whether they want to or not pay you. The sellers in this marketplace, the security researchers, don't have any power. And it's not surprising that almost all of the bug bounty programs have a terrible reputation for not paying. And that makes complete sense. Why should they pay? They have exactly 0 market pressure to put a fair price. And they have only a small amount of reputational pressure to pay anything at all. So, if you're a capitalist, you'd think, well, there's another way. We could go and try and sell this vulnerability on the various dark websites. But if dealing with Apple was bad, dealing with the dark web is far worse. These sites generally require you to build reputation in order to get access to the invite-only message boards. And just like with Apple or Google, you need to disclose the nature of your research, the details of it, working exploit code, to market moderators so that they can verify your discovery before it can be listed. So as a seller, you need to both gain reputation for access, and you still need to trust a third party to verify what you've discovered so you can sell it. And you need to trust that that third party won't steal what you've discovered and sell it for themselves. This is a pretty bad situation for researchers, and especially bad when they've discovered something that could, in theory, be worth millions of dollars. Enter ErasureBay. ErasureBay gives security researchers a fair place to sell their discoveries, a decentralized marketplace that enables real price discovery and doesn't require you to build reputation and doesn't require you to trust any third parties. So if I'm that software researcher and I've discovered that security flaw in iOS, I can encrypt what I've discovered, upload it to ErasureBay, and then let's say stake $5,000 on the validity of my claim. And then let's say Apple sees my listing and they read about what I've discovered. And then they offer to buy my discovery for $100,000. Since I'm brand new, let's say, to ErasureBay, I have no reputation. Apple and I are going to negotiate, and we're going to agree on 100-to-1 griefing terms and a 30-day griefing window. So once we've made that agreement and Apple's payment has gone into escrow, Apple can download my research and they can examine it for that 30 days. And if they're satisfied, then after that period of time, the $100,000 payment comes to me and the $5,000 stake that I've made gets returned to me. But let's say they're not completely satisfied. Within that 30-day period, they can use that 100-to-1 griefing ratio to spend $1,000 and burn that $100,000 payment to zero, and $50 to burn my $5,000 stake. Erasure's system of staking and griefing allows buyers and sellers of information to come together in the open without trusting anybody, not even each other. We think that 0 days are the perfect first use case for ErasureBay. The types of people who are currently buying and selling software vulnerabilities are exactly the kinds of people who, much like Numerai data scientists, are able to cope with the quirks and oddities of today's decentralized web. But as dApps get more consumer-friendly and the crypto on-ramp becomes smoother, we see a world where everybody's information can become expensive because everybody knows something. Now to explain the protocol, I want to introduce Stephane.
Thank you so much, Peter. All right. I hear myself, which is a good sign. So, ErasureBay. We talked a little bit about ErasureQuant, and we talked a little bit about Numerai as well. What we haven't talked about yet is the protocol on which each of these are built. So that's what I'll talk about. This is really Numerai's platform moment. With Erasure, Numerai goes from being a single product for a single hedge fund to being a platform, a protocol that has the power to bring Web3 primitives to every single website on the internet. These primitives, these are the core components that allow you to do this. And we have 3 of them to start with. We have recourse, which is this idea of skin in the game that we've been repeating. By staking on the blockchain and giving someone else the right to burn it, you're able to align incentives. The second is track record. On the blockchain, everything is permanent. This means that you can build a history with public timestamps that you can prove to everyone who's watching that you knew something at a certain point in time. The last one is payments. This is about enabling value exchange on the internet with programmable escrows. Let's take a closer look at recourse. Skin in the game. Traditionally, in order to achieve it, you'd have to sign some kind of service level agreement, and you'd rely on the legal system to arbitrate it. But the legal system isn't built for the web. It doesn't work when you don't know the person that you're communicating with, if they're anonymous. So we had to engineer an alternative, one that happens through code instead of lawyers. And we call it griefing. If Alice and Bob want to engage in an agreement, they create a griefing agreement, smart contract, on the Ethereum blockchain. But that's pretty complicated. So instead what they do is that they connect to an Erasure client. This client can be in the browser, it can be a command line tool, a mobile app. It really doesn't matter. That's because it's completely serverless and it can run on any device. Really what the Erasure client does is it provides a gateway into the Erasure protocol. The key vault stores all the encryption keys that allow you to communicate confidentially and send files to the other peers in the network. The wallet is actually a smart contract that enables you to store all your cryptocurrencies in one place securely. And the data store is a place where you can back up all your information both locally and in decentralized storage. Finally, the Web3 provider is what connects you to the Ethereum blockchain. Since the Erasure client handles all the complexity of the blockchain, Alice and Bob don't need to. You can simply inject this client into any application and unlock the full power of the protocol. But let's get back to griefing. To create a griefing agreement, either Alice or Bob needs to initialize it with a duration and a griefing ratio. This griefing ratio informs how much you need to pay and to be able to punish the other party. Let's say Alice is a staker. Once she submits NMR into the smart contract, this gives Bob access to the punish and the reward function. If Bob then decides that Alice hasn't fulfilled what she set out to do, he can send NMR into the smart contract, which then burns his NMR and a part of Alice's stake based on the previously agreed upon ratio. And finally, once the duration of the agreement is complete, Alice is able to retrieve her stake. This is actually quite a simple configuration of what a griefing agreement could look like. But it's very extensible such that you could actually put conditions on when griefing can happen based on arbitrary conditions. Like this, you're able to bring recourse into these applications that would previously rely on a trusted third party. Let's talk about the second primitive, track record. It's really a core component of Erasure Quant. It's about allowing counterparties to evaluate the credibility of your history by looking at these immutable claims on the blockchain. The way that Alice can create a track record is by sending data to the Erasure client. This could be stock market predictions or a zero-day vulnerability. What the data is really doesn't make a difference. That's because the Erasure client treats all data the same. First, it generates a symmetric key in the client, encrypts the data, and uploads it to decentralized storage. This is critical because then it allows Alice to recover her data from any device. Decentralized storage in this case is preferred over uploading to a platform like Ethereum because it's way too costly to put data on Ethereum itself. The next thing the client does is it creates a proof hash. This proof hash is actually a multi-hash that contains both the Ethereum address of Alice, a salt, and her data. Now the user address is necessary because it's what identifies that Alice could have been the only person to submit this data to the blockchain. The salt obfuscates what the data is. It prevents attackers from being able to decrypt it without her explicitly sending them what the data is. And finally, the multi-hash is a self-describing hash that allows for future proofing of Alice's feed. It allows multiple different hash functions to coexist in continuous history. Once this proof hash is on Ethereum, It's what we call a proof of existence. Anyone in the world can see that Alice owned this data at this specific point in time, and there's no way for her to reorder it. As she continues to submit proof hash, she starts to build this immutable track record. When at a later point in time, Alice decides, great, my predictions have come to pass, I can now reveal them, she uploads that data to decentralized storage and lets anyone verify that it matches the hash that she previously submitted. Third primitive, payments. This is really where cryptocurrencies shine. They're unquestionably the best way to transfer value over the internet. That's why Erasure allows for payments in any cryptocurrency. But cryptocurrencies don't give you everything. For example, if you're buying a zero-day marketplace on a platform like ErasureBay, you'll need additional guarantees that you're getting the real deal. So you want to put your money into a programmable escrow that's set to trigger only once the 0 day has been sent to you. Let's take a closer look at what that looks like. So in this case, Alice is the seller and Bob is the buyer. Bob starts by generating a public key, a public encryption key, using a library like libsodium. He stores this key in the Erasure user registry. This allows anyone in the network to notice, great, I can now communicate confidentially with Bob. The next thing he does is place NMR in an escrow contract and sets the parameter of the contracts such that it's only triggerable by Alice when she reveals her data. Alice sees that Bob has committed these tokens and submitted his public key. So she retrieves this public key and gets ready to send him the message. Meanwhile, she creates a symmetric key in her own Erasure client. This can be done with a library like Fernet. She uses that symmetric key to encrypt the data that she wants to send to Bob and uploads that data to decentralized storage. She then encrypts that symmetric key with Bob's public key and submits that key to the escrow contract to trigger the trade. Once the escrow contract validates that the trade is valid, it executes it and sends Alice the tokens while Bob receives the encrypted key. With that key, Bob can automatically retrieve the data from decentralized storage and get immediate access to it. So those are the three primitives. But really, we're just getting started here. As the Erasure protocol continues to innovate, we will build other primitives that allow for Web3 to be plugged into every single website on the internet. What that website is, that's up to you guys. Great. So we've talked about the what, but not yet about the how. These primitives need to be translated into code that can live on the blockchain. There's a pretty big challenge when you work with the blockchain. Everything that you put on there really wants to be permanent. Every action that you take is irreversibly etched into the history, block by block by block. That means that if you deploy a smart contract, that contract is going to stick around in perpetuity, except for some examples, but we don't talk about those. That means that a lot of work needs to happen designing the system up front. Because if you get it wrong, in the best case scenario, you have a failure to upgrade and be able to implement new innovation as it comes out. In the worst case scenario, a simple bug can bring your entire project to its knees. But there is actually a holy grail of an architecture. There is this holy grail that every protocol is aiming for. The first thing is that it needs to be decentralized. There can't be a single point of failure. It can't be possible to censor the users. The second one is to have a single source of truth, so there's no confusion. Where should I be looking to see where my tokens are? The last one is that it needs to be future-proof. I need to be able to implement new innovation as it comes out. And lastly is security through modularity. If we look at the way that protocols have been built so far, what we found is that there's often trade-off decisions made between these properties. For example, with swappable modules, you have this core smart contract that's able to interact with these other modules that are swapped in and out. In theory, you can implement anything in those swappable modules, but you're always limited by the power of that initial smart contract. Another alternative is to do fork-based upgrades. This is where you release a new version that completely replaces the initial version of the protocol. But once you have two different versions up on the blockchain, then you have to go around and try to convince everyone to switch over to the new version, and it can be contentious. So you lose a single source of truth. And then finally, we have proxy-based upgrades. Here you get to keep the single source of truth, but it comes at the cost that the developers who are shipping this upgrade have complete control over the protocol. And so you lose decentralization, and you lose modularity. So these decisions, so far, have forced every project to make severe trade-offs, but until today. So I'm here to talk to you about a bit clone factories. These clone factories are a new kind of architecture that we've put together to meet all these requirements. They're decentralized by design, which means that there's no shut-off switch, and it's impossible to censor users. The single source of truth comes from the clone registry. It sort of sits on top of all the activity on the protocol and makes sure that every single clone is registered and lives in it in perpetuity. Adding a new feature is actually as simple as creating a new clone factory. You create a new template, for example, an escrow template, and you add it to the registry. At that point, any user can start creating these clones that copy the template over and copy all of its logic. But each of these clones are completely modular. They have no references back into each other, which means that if one of them goes down, it doesn't take its compatriots down with it. If you want to learn more about this architecture, we have a blog post that's up about it, and it's what we use for the Erasure protocol. So there you have it. The three primitives of Erasure: recourse, track record, and payment. With these, we're able to build 3 products that were never before possible. And now so can you. So help me welcoming Richard back on stage to talk a little bit more about that.
Thank you. Well done. So I hope we have made the case that ErasureBay will be a website that anyone can use for all kinds of weird things. 0 Day is a great first example because it appeals to technical people, and technical people can use Web3 technologies. But you can imagine all kinds of other things if you could have staking and griefing on the internet. Imagine you had an eBay page, but on that page, you could grief the seller if you were unhappy with the product that they shipped you. You try to buy something, they sent you something else. Okay, sure, you could return it to them like a normal person, but you could also destroy their money on the blockchain like a futuristic person. So that would be a really weird world. And it's not about doing the destruction. It's about the fact that that person won't send you bad stuff because they know you can do that to them. Imagine you could stake yourself in like a Google Chrome extension, and because you've staked yourself, all your comments on Reddit go to the top. Or imagine you're matching on Tinder with someone, and You match with Tinder on someone, right? You're swiping around, you match with someone, and then they don't show up to the date. You can burn their money. Amazing. That's kind of messed up, actually. The point is, Erasure can spread across the web. And a lot of people have said, is this kind of a distraction? Why is a hedge fund making a whole protocol? And the point is, like, all we have to do is make the protocol, and then other people can run with it. So we're kind of having this event to find developers who are interested in making applications. And we actually had a whole grants program where a bunch of people have applied to make all kinds of different applications. And some of them are sort of like people with ideas who don't have technical co-founders. Some of them are developers without ideas. And we're going to put them all together and have them start to make applications. ErasureBay is an application we've kind of almost already made. It hasn't launched yet, but it's almost ready. But if someone copies ErasureBay and makes a whole new ErasureBay that's got way better design and is way easier to use, like, we actually want that to happen so that we can, run a hedge fund. So we're not going to make many more applications. This is probably the only ones we're going to make. And hopefully, a year from now, if we do this event again, most of the stakes and the burns of NMR will be to do with applications that we had nothing to do with. So we want to get developers, but there is one more thing we want to do that. So I want to talk a little bit about CoinList. And we're going to be doing a huge hackathon with them. And so to explain that to you, I want to invite them up.
Thanks. Hey, how's everyone doing? I'll talk briefly about CoinList, what we're doing with Erasure, and how excited we are. CoinList was built to help crypto networks launch and succeed. We launched about 2 years ago as part of the Filecoin offering, and basically built a platform for companies to run token sales so we could abstract away operations, compliance, legal issues, all of that, and just help crypto protocols focus on raising money and getting back to building. Since then, we've worked with companies like Filecoin, Algorand, Blockstack, and helped teams raise over $500 million. And sort of the way we've approached product since then is, well, what do companies need help with after launching, right? We've worked with some of the top teams in this space on their initial fundraising. What happens after that? What do you need to help launch a successful network? And in all of those conversations, everything came back to developers. And so about a year ago, we launched Build, which is a platform to help crypto networks engage developers, initially through hackathons. When we looked at Web3 and why we're excited about what teams are building in the space, the global nature of it, networks being permissionless, all of this really stood out to us. But the way that most teams in this space were engaging developers seemed like it was the same way people were doing 10 years ago. A bunch of developers that could afford to do so would fly to an ETH hackathon in some city, they'd build for 2 days, and then they'd go back to their normal jobs. And we thought there was a better way to do this in a much broader and inclusive way. So we launched in January working with 0x in a hackathon, and since then have helped about half a dozen other crypto networks, teams like Coda, NewCypher, Dapper Labs, engage thousands of developers from 40 countries. And through things like online workshops, setting up prizes for them have helped teams from all over the world engage with some of the best technologists and investors in the space, and have deployed about over $100,000 in prizes. And a lot of these teams have now entered grant programs, some of them have raised money, and they're still working full-time on these protocols. And so we're really happy to be working with a team at Numerai on Erasure, really excited to see what people build. And actually, developers can now sign up for the hackathon, which is launching in a few weeks. We're really excited to get started.
The next chat is going to be with Joel. Joel was formerly at Union Square Ventures, and when Numerai was just a few months old, we met. I think he found us online or something, and it's one of the first investors I'd met when we were talking about doing a Series A round. And in the very first meeting, we were talking about tokens. And this was a long time ago, back in 2016. And since then, Joel has founded Placeholder. And earlier this year, Placeholder invested in Erasure by leading a round in NMR with Paradigm. So I want to welcome up Joel.
Thank you.
You're welcome.
Now I'm a partner in general.
So one of the things that we've talked about is how Numerai's transition from this quite specific thing into something general, whereas other projects have started with something general and then kind of faded out. So because they didn't find anything specific. What do you think about our approach?
So that is something that happens with the best ideas. They become bigger rather than smaller. It's something that my partner Brad and former boss at USV would tell me that a sign of a company succeeding is the idea would get bigger. And with Numerai and Erasure, I've had an interesting kind of progression of my understanding of the opportunity, working with you in the beginning with Numerai before Numerai existed and you were doing payouts in Bitcoin, all the way to now this decentralized marketplace. And what's interesting about that progression is that we're talking about many of the same core ideas. We're just realizing how they can be applied to much broader contexts. And going from Numerai to Erasure, you described it as taking out all of the things that make it not decentralized or that make it challenging to work with. But most recently, as we've been working through Erasure, what's blown my mind the most is realizing how much of the world and the applications that we use on the web today rely on predictions. So for example, when you are on Amazon and they suggest a product that you might also want to buy, they are predicting the likelihood that you buy this product. Or when Google displays an advertisement, they are predicting the chances that you're going to click on that. And all of those are little predictions that power the web services that we use today. And so that is one way in which Erasure becoming more generalized is becoming clear in my mind. But also, as we've had these conversations, realizing that Erasure is not really about predictions. Predictions is just one kind of data. But starting with predictions is actually quite interesting because it's probably, data is already difficult to work with as an information good, as an economic good. Predictions are even harder to work with. And so what works for a difficult object like a prediction also works very well for general information. And exploring all of those ideas has been really interesting.
Yeah, we just talked about this 0-day kind of idea of this is some valuable information, but it's not a prediction. But it sort of is in a way, right? It may be the vulnerability.
Right.
So it's sort of does generalize. It may be the vulnerability or it may be fake. So it does generalize. And I originally wrote a lot about Erasure as being, I wrote about Erasure Quant, right? I was just writing about, I had thought about another way to use this token for the field I'm in.
Yeah.
But then as we've developed it, it started to be clear that you could really use it for anything.
Well, you're catching information before it becomes, you're catching predictions before they become fact. And so once something becomes a fact, it's no longer as valuable as when it's a prediction.
Right.
But then when it's a prediction, you can't price it very easily or put a value on it very easily because it hasn't become a fact yet. And so these are the things that make information very difficult to work with in an economics context. But what Erasure does is provide a standard set of variables and mechanisms for the market to be able to price information in a much more efficient way than we could before. In my exploration of this, I ran into something called the lemon problem in economics, which is the notion that there are certain goods or certain markets where you can't verify or validate the quality of a good until after you buy it. And that certainly applies to information more than any other kind of economic good. And it's a really difficult problem to solve. But Erasure provides the tools to get as close to the solution as possible.
Yeah, I often think one thing we've talked about is the kind of what the internet would look like if you had negative incentives, not just positive incentives. So when you put content on Facebook, you're doing it for the likes, right? It's a positive incentive. But there is no risk of a negative incentive. Facebook maybe actually is a kind of bad example there because they're using your real personality, your real personal identity.
You must not have a lot of trolls.
Yeah, so because they're using your real identity, maybe you have this like reputation risk, which is this negative incentive. But other websites, you kind of don't care what people think of you on those websites.
But even in that context, you could say, something like Reddit has a negative incentive and a downvote. But there's still a number of other issues with, for example, spamming or Sybil type attacks that you solve when you have something scarce mediating the exchange, like a token. And so there's, in finance, for example, if we go back to the financial context, something that could have happened on Numerai pre-token that doesn't really happen in traditional financial markets is the idea of someone submitting lots of random predictions and models and then until one of them hits. And you can't do that as an investor because you will run out of money. And that kind of takes care of itself that way. You recreated that constraint with Numerai because you could only submit as many models as you could afford to stake behind, almost as if, recreating the same kind of condition where there's a limited amount of information that you can kind of put to work. And so taking that idea and expanding it, the idea of a rate limit in a way, and expanding it is also something that can be applied to other kinds of information markets.
Yeah. Do you think that people talk a lot about on-ramping and just general usability of Web3? Some people seem to have made products that are actually quite usable if you have MetaMask and you have tokens already and you've kind of done it before. Do you see that as going away? It doesn't seem like in the last 3 years really many more people are using these things, but maybe that's just I haven't been paying enough attention.
So what came to mind as you were describing that was the first time I set up a modem in my house was very difficult. I had to get a modem. I had to get an internet service provider. This was dial-up. I'm not that old, but it's pre-internet floating in the air. And so we're from a generation that we had to do that. We had to learn how a router works, what Wi-Fi is, what servers do. When the internet was new, we needed to learn all of those concepts. But it took a long time for it to become seamless, where now it floats in the air and people coming to the internet for the first time today, kids, don't really think about those things, and they don't have to. The user experiences are getting much better. It seems like it's by the quarter, and you can tell I work in finance because I time myself in quarters. But the last year has really been groundbreaking for the crypto experience. We're nowhere near, Well, I shouldn't say nowhere. We're closer to a mainstream user experience, if you consider the web standard as a mainstream, than we were ever before. And right now, the biggest hurdle is no longer user experience as much as the connection between the legacy financial system and crypto, where what's really hard is the fiat on-ramp. How do you turn money that you already have, that is, fiat money, how do you turn that into crypto? And perhaps unsurprisingly, that has been the biggest hurdle to cross, because it's fraught with all kinds of regulation and all kinds of difficulties. But how I think that goes away in the future is, I think it's a problem today because the main mechanism for getting a hold of crypto is to buy it. But we are transitioning into more models, especially as new networks launch, where I think long-term, most people will come into crypto by earning it and making it natively so that you won't even have to turn your paper dollars into digital coins. You will just earn in digital coins. That's how I think the next 20, 30 years of progress are going to look like.
That's really interesting. One last question. Your firm is quite famous for writing theses on the projects that you've got involved in. What is your kind of thesis about Erasure and NMR, and how do you see it evolving, playing out?
So for us, it started with the context of Numerai and the context of financial predictions. And really what attracted me about Erasure and the design was, if you think about the professional practice of an investor, the investment management business, there's kind of two main areas of activity. You've got insight generation, which is coming up with investment ideas. And then you've got investment execution, which is actually performing the transactions to execute that investment, buying the stock or doing those things. And that's kind of universal across finance. So for example, I'm a venture capitalist, so a lot of my transactions are negotiating with founders and working with lawyers, and it takes weeks. It's very expensive. If you are a hedge fund, then you are plugged into a variety of exchanges and you can do it programmatically, but it's still those two main areas. Someone's coming up with the insights, and they're typically also doing the execution. But so far, those two activities have been bundled, where you start a firm and that's what the firm does. But with Erasure, we have an opportunity to unbundle those two areas of activity, where someone can be working only on the insights and selling them on Erasure, and someone can be on the other side doing the transactions, having bought the insights from Erasure. And because you have the market mechanisms for those insights to be priced appropriately, then long-term, in theory, someone should be able to make an investor's living by coming up with the insights wherever they are in the world, and they don't have to run a hedge fund in New York in order to capitalize on the value of their information. And that is a pretty powerful change in the paradigm of how investment is made and how capital is allocated across the economy. Because what's kind of problematic about the current setup is that most of the value is in the insights, but most of the costs are in the infrastructure and the execution. That's actually what's expensive. Paying lawyers and having a firm and having these systems and doing all of those things for the sake of actually executing on the insights. And so a lot of people have the talent and the skill to come up with the insights, but none of the infrastructure, and so they're completely shut out from this activity. So making that, opening up that process and unbundling those two functions is something that's very powerful. But as we've gone through the different cycles of ideation with Erasure and the conversations that we've had, that idea has expanded even further, where once you step outside of finance and go into the broader realm of information, which happens to be pretty much everything in the world, we start to see how Erasure can become a component for many different kinds of applications, even if the data that you're dealing with is not predictive.
Great. Well, thank you, Joel.
Thank you.